So we're all pretty familiar with the idea that if this is my horizon, it appears that the sun rises in the east and sets in the west. So here's my sun going across the daytime sky. We have noon, it's highest in the sky, okay, and it sets. Now, I'm sure you probably know that this is actually due to the Earth spinning on its axis of rotation. So we have, I don't know how to draw this, but we have the Earth spinning and it's counterclockwise. It's all about counterclockwise in its axis. And so the sun stays in the same place, but it's our spinning, our rotation, that makes it appear to rise and set. And as it turns out, the stars do the same thing. If I were to be able to see, and I can't because of Rayleigh scattering, but if I could see some of the stars in the background that escort the sun across the daytime sky, I would see them also appear to move across the sky. And so that gets me to the point that I'm after here, is that the stars appear to move just as the sun appears to move across the sky. Those things that move across the sky because the Earth is spinning on its axis that motion is called diurnal motion. It's an apparent motion, right? Those things aren't orbiting the Earth. They just look like they're orbiting the Earth because the Earth is spinning. Diurnal motion. So now to add to that, though, we said a few videos ago that actually if this is the Earth, its axis of rotation is tilted, and its northern axis of rotation is actually pointed to the star Polaris. Okay, so that's Polaris. And Polaris actually right now anyway, and I'm going to talk about this at the end, Polaris right now is our North Pole star, so it's the NP star. And related to that, actually, we will see, and you're going to see on the next slide, that if, as I said, the stars appear to move, and, let me just go to the next slide. What you're looking at here is Polaris, okay, and this is a time-lapsed image, basically, of taking stars over the course of taking lots of pictures of stars as they move, and stars will appear to move counterclockwise. Okay, oh, did I do that right? No, I did that wrong. The counterclockwise, there's my counterclockwise, around Polaris. And so you just watch. If you look at Polaris, you'll kind of see them kind of shift. Now, we're going to talk about constellations coming up. Now, they don't move randomly. They move in kind of rigidly, and of course, they make these awesome, there's the Little Dipper. They make these awesome sets of stars we call constellations or asterisms. So here we have the stars going counterclockwise around Polaris, making these cool star trails. Now, if the star is close enough to Polaris, it will make this full bullseye, okay, like a full circle, and we say that those stars don't set, and those stars then, for that location anyway, are what we call circumpolar stars. So they never set. Now notice these that get wider than are further from Polaris, so these will appear to rise in the east and set in the west. Rise in the east and set in the west. Sound familiar? Just like our sun does. Okay, so that's diurnal motion of the stars, and that's a star trail. I just think that's so pretty. So counterclockwise around Polaris. It might be kind of hard to explain without showing you, but as it turns out, if you take your horizon, I don't know how to draw this. If you take your horizon, okay, and you take the angle that your horizon makes with Polaris, that angle right there actually is going to tell you where you're at with regard to lines of latitude. So the angle that Polaris makes with the horizon is actually the latitude of your location. So as it turns out, we are, and that's why in folks a long time ago could use that's one way that sailors could know where they were with regard to latitude. They could use the North Star if they're in the northern hemisphere anyway. There is no southern pole star right now.